So I credit Gutzwiller for being the founder, the person who had this idea. And it took about 20 years between his papers published in Journal of Mathematical Physics and actual implementations where people actually computed stuff. And once it started going, it was really pretty impressive. And the helium was computed to some accuracy, but pretty good, 10% to 1% in the spectrum. And then there were experiments which are totally amazing. So the experiments were, you have a hydrogen in a magnetic field, and you measure 1,000 spectral lines of this thing. So it's hydrogen, you do good experiment, atomic physics experiment, you get a very complicated spectrum. Then you do, if you remember, our idea was that on the right-hand side we had eigenvalues, that's the spectrum. On the left-hand side, we had sum of periodic orbits. So that means in experiment you measure the spectrum. So then what they did is they did a correct kind of Fourier transform to produce the periods of the periodic orbits on the other end of the sum. So this is atomic experiment. This is hydrogen. There's no classical mechanics anyplace. And they measured an experiment that the sum was dominated by returning orbits which are classical orbits of electron going away from hydrogen and coming back. This is the period you compute classically. So, you could measure this in atomic systems. So this duality is not just some mathematical fantasy. It's a thing that relates it really relates spectrum to spectrum of evolution opera, which in quantum mechanics is a unitary evolution opera, to the spectrum of lengths of periodic orbits. So its duality is, energy to time, and you're getting periods of periodic orbits.